This is video number 4 from digital-university.org. Here we're presenting our series on electrical circuit analysis, and for this video we're going to determine the equivalent resistance of this circuit right here. These are all just straight ohm values. There's no mega ohms or milli ohms or micro ohms. It's just simply 5 ohms, 30 ohms, 20 ohms, 200, 30 ohms, 20 ohms, and we want to find the equivalent resistance of this circuit. As you can see, we have combinations of series resistors and series and resistors that are in parallel throughout the circuit here. Now, here you might look at these two and decide, well, these are in parallel, the 20 and the 200, and they are, but the more important observation is that the 30 ohm resistor and the 20 ohm resistor are in series with each other. So let's just first of all just draw them in series on a single line to make it more apparent. So here's the 30 ohm resistor, and here's the 20 ohm resistor, like this, but then clearly they just add up to give a single resistor with a value of 50 ohms. So let's write it like that. So now we have a single resistor here that is in parallel with the 200 ohm resistor over here. So these two that are in parallel with each other, we can find their equivalent resistance. That is equal to the product, 200 times 50, divided by their sum, and that is 250. So here we have 10,000 divided by 250, or 1,000 divided by 25. So that equals 40. So these two resistors have an equivalent resistance of 40. So let's just draw that in the circuit then, or redraw the circuit actually. Here we have the 5 ohm resistor. And then the 20 ohm resistor. And then the equivalent one between these two is 40. So there's the 40 resistor, or the 40 ohm resistor. And then we got a 30 ohm resistor across here, like this. So this is 5 ohms, this is 30 ohms, this is 20 ohms, and this is 40 ohms. And again, this 40 ohm resistor is the equivalent of this 200 and this 50 ohm resistor. And we can see it's in parallel with the 30 ohm resistor. That's true, but again, the more important observation is that these two resistors are in series, so we can draw them as a single resistor that would have a value of 60 ohms. So let's get rid of one of them and make it this one. This has 60 ohms. Now, I drew the circuit like this, but clearly this resistor here is in parallel with this resistor here. What we can do is, that this is just a straight conductor, so you can think of just taking this, going down like this, or we can draw it in the conventional sense to make it a apparently obvious. This. The 30 ohm and the 60 ohm being in parallel with each other. And now we can find the equivalent resistance. These two resistors in parallel, the equivalent resistance is this product divided by their sum. 60 plus 30 is 90. So here we have 60 times 3, and then 80 times 30 is 1,800 divided by 90. That's 180 divided by 9. So that's equal to 20. So we can replace these with just a single 20 ohm resistor. So let's do that. This doesn't need to be there anymore. And we have it going like this, except this is now 20 ohm resistor. And then clearly the 20 ohm resistor is in series with this 5 ohm resistor. So finally, you can see that these just add up so that the equivalent resistance is 25 ohms. Okay, so we go back, look at this. With this entire circuit then, the equivalent resistance is 25 ohms. Okay, again, hopefully that was a pretty straightforward example. We have 3 more videos where we determine the equivalent resistance of different types of circuits. And the next 3 will be a little bit more sophisticated. Hopefully they'll give us a better workout of our principles. So come back and join us for those videos, and we'll see if we can solve some more problems.